my wonderful chemistry students. If you were not here the first day that we started Chemistry Unit 9, then I want you to watch this video, fill in notes as we go. It shouldn't be too long, and then when you get back, we will dive into the activity that I had planned, so I won't need to be tagging any of you guys for homework because we decided to wait and do that activity after you guys all got back from your trip. Okay, so reminder really quick that this not this Friday, but this upcoming Friday the 7th, February 7th, is the last day for corrections or retakes on Unit 8. So any Unit 8 items, last day for corrections or retakes. So if that is you, I put all of those scores in PowerSchool, so check your chemistry grade, and if it's not where you want to be, make sure you come talk to me and we get corrections and retakes done on or before the 7th. Alright, so let's keep going. So we're looking at page 5 right now, and this whole unit is about chemical reactions. So the first thing I want to point out to you is that we have these like plus signs, and it just separates either reactants or products. So I have this reactant, and this product. So when we are on the left-hand side of the arrow, these are our reactants. And when we're on the right-hand side of the arrow, this is our products. So reactants and products. Now, an important part of chemical reactions is that the number and type of atoms are conserved. Mass is conserved. So if I have one sodium atom in my reactants, then I should have one sodium in my products. But what we're realizing here is that, okay, wait, there's a subscript. And this subscripts tell you the number of each types of atom in a molecule or compound. So subscripts. Okay, so again, the subscripts tell you the number of each type of atom in a molecule or compound. Okay, great. So this means that there's 2 chlorine atoms in this one molecule. Like if I were to draw this, here's a chlorine and it's bonded to a chlorine. And so in this one molecule, there's 2 chlorine atoms. But here we don't typically write subscripts if they're a 1, but there's 1 sodium and 1 chlorine. So whenever we go to balance a chemical reaction, we can't change subscripts. I can't draw a little subscript 2 down here, but what we can change is the coefficient that goes in front. So I could put a coefficient of 2 out in front. So this is coefficient. Okay, now coefficients tell you, so let's write it down, coefficients. They don't tell you the number of each type of atom, they tell you the number of items. Okay, the number of items in the reaction. So if I have a 2 here, that applies to everything behind it. I have 2 of these NaCl's. So I have not just, I'm going to draw it up here. Like if this is, and we'll look at it in a moment, but if this is like my Na and my Cl, and there's an ionic bond between them, this compound, this ionic compound, this is one NaCl. So that would be one of them, but we need 2 of them. So this would be 2 NaCl's. So I can see from that that there's both 2 sodiums and 2 chlorines. Okay, so great. Now we have 2 chlorines on the reactant side and 2 chlorines on the product side, but we added this coefficient of 2, so we have 2 sodiums, so that means I need to put a coefficient of 2 out here as well. Okay. So like I told you, the plus sign is used to separate like reactants and products. The arrow is like a yields or produces. This double arrow is really cool. We're going to learn more about that either next unit or the unit after. I can't remember. Reversible reactions. They're reactions that go both forward and reverse. And S means solid. So this sodium is solid. An L is liquid. A G is gas. So the chlorine is a gas. And aqueous, AQ, aqueous, dissolved in water. We're going to learn more about those later. Okay, so what does this look like at a molecular level? Well, let's add those coefficients again. So we have a 2 and a 2. I'm going to make a key. So let's say if I have one that's colored in, that's going to be sodium. So that's going to be sodium. And if I have one that's not colored in, that's going to be chlorine. Okay? Now I want you to pay close attention to how I draw this. So I have 2 of these NAs, and I have 1 of these Cl2s. Normally we don't write the coefficients when they're a 1, but I'm going to put it there so we can see it. So I have 2 sodium atoms and 2 chlorine atoms, but look at how different these are. This is the difference between a subscript of 2 and a coefficient of 2. So a coefficient says I have 2 of whatever's behind it, and what happens to be behind it is a single sodium atom. So here's 1 sodium atom, and there's the second sodium atom. They are not chemically bonded. Where this is a subscript of 2. So that means that in a molecule of Cl2, there's 2 chlorines, but I only have 1 molecule of this, 1 connecting molecule. And this is going to make 2 NaCls. So here's my sodium, here's my chlorine. That is 1 Na and 1 Cl, and they're chemically bonded. But I need 2 of those. Now what's really great about drawing these out is you can check if you've balanced it correctly if mass is conserved. Because I see 2 chlorine atoms on my reactant side, and I see 2 chlorines on my product side. And I see 2 sodiums on my reactant side and 2 on my product side. Okay, let's do one more of these. In this reaction, we have carbon, we have oxygen, we have hydrogen. So if it's a bigger one that I color in, that's going to be carbon. If it's a bigger one that's not colored in, that's going to be oxygen. And if it's a smaller one that's not colored in, that's going to be hydrogen. If you want to pause right here and try to do this first, that would be great. If you want to follow along and color it in with me, that's fine, like do that, but whatever you want to do. So either try it on your own, pause it, and then join me again, or follow along with me. So I'm going to add the coefficients of 1 to help me out here. So I have 1 of the CH4 molecules. I have 1 of the carbon dioxides on the products. So I'm going to draw this molecule first. So I have a carbon and 4 hydrogens. So carbon and 4 hydrogens. And these are all chemically bonded, and that's why, because they're a subscript and then they're in the same formula. So 1 carbon, 4 hydrogens. And I only need 1 of these molecules. Now, if the coefficient subscript thing, if we're a little confused by this, I want you to ignore a coefficient at first. So when I go to draw this, I'm going to ignore the coefficient, and I'm just going to look at the subscript and the molecule. So I have an O2 here, and these things are chemically bonded together. So it'd be like, I'll draw right here, not a single oxygen atom, but 2 oxygen atoms. That's what the subscript 2 means, and they're chemically bonded together. That would be 1 O2, but the coefficient tells me I need 2 of these, so I'm going to draw that a second time. So this would be 1 CH4 and 2 O2s. And this produces, let's do one of these first. So I'm going to ignore the coefficient. I'm just going to look at H2O. So here's my oxygen. Here's my hydrogen. So we draw them like Mickey Mouse because they get like kind of bent. So like there's my my oxygen, my hydrogen, and my hydrogen. H2, 2 hydrogens, 1 oxygen. And now we see there's a coefficient of 2. So this is 1 H2O, and there's 2 of these. So I'm going to draw another one. Okay, great. And then we have a carbon dioxide. So here's my carbon. And then there's 2 oxygens. So there's my carbon dioxide. If you do not draw these bent, that doesn't matter, but what I need to see is that there's 1 oxygen and 2 hydrogens, and they're chemically bonded together. Same with the carbon dioxide. It doesn't matter if you drew it in a straight line. I just need to see that there's 1 carbon atom and 2 oxygen atoms. So now what if I give you a key in the picture? Can you do the chemical formula down below? So let's say they're wanting to do like a water again. So sure, that means the ones that are not colored in are going to be hydrogen, and the one that is colored in this time is going to be oxygen. So when I look at this, I have this molecule, and it's a hydrogen and a hydrogen. So this single molecule is an H2. But there's 2 of these, so this would be a coefficient of 2, 2H2. Now, over here, I colored in and colored in, so oxygen and oxygen. So this is an O2. It's a subscript of 2 because they're covalently, chemically bonded together. So I have 1 of these O2 molecules. Now, a single one of these molecules, so I'm just looking at this guy here, it contains 2 hydrogens and 1 oxygen. So we get this H2O, right? 1 oxygen, 2 hydrogens. That's 1 H2O, but we got 2 of those. 2. Okay, and last thing, and then this video will all be wrapped up. Later on, you're going to see that there are certain elements, when the atoms are all by themselves, they will covalently, yeah, is it always covalent? I believe so. Covalently bond to themselves, meaning I have like free-floating oxygen. It will find the other oxygen atom, and it will chemically bond into a molecule, and these molecules are called diatomic molecules, when 2 of the same atoms are covalently bonded. I'm going to get a periodic table. All right, so there are 2 ways of memorizing which elements, when they're all alone, are going to become diatomic molecules. The first way is remembering it's like a funny name, Brinkelhoff. Okay, Brinkelhoff. When any of these elements are by themselves, they'll form a diatomic molecule with a subscript of 2. These same elements are next to each other on the periodic table, and they make this like upside down and backwards L shape right here, and hydrogen. So what are these diatomic molecules? They're Br2, I2, N2, Cl2, H2, O2, and F2. Okay, thank you so much for following along and filling out your notes. I look forward to seeing you all in class, and we're going to be doing an activity where we're going to balance chemical equations.